Yeah, it is. There we go. So if there's no number down here in the root, we understood that it's a square root, correct? Well, we can also write that as 8 to the 1/2. So if I've got a fractional exponent, my denominator is my root. The denominator is the root. The numerator is the exponent. So I can say 15, the cubic root of 15 is really 15 to the 1/3, because it's the cubic root. And so the 3 is the denominator. Does that make sense? If I say the 5th root of 32, then I'm saying 32 to the 1/5. Now, negative signs are kind of funky. You need to be careful about where it's placed when you're rewriting it. Notice that this negative sign is outside the root. So I can write this one as -4 to the 1/2, which we know this one to be what? Negative. And we know this one to be positive 2. Okay? Yes? Because if it's the 5th root, then it's the 1/5 power. Just like if it's the cubic root, it's to the 1/3 power. And if it's the square root, then it's the 1/2 power. Okay, so our roots are our exponents as a fraction. Okay? Okay? Thanks. Emma? Is that you got a question? Yes. Are you with me? Okay. Okay. Okay, so what does 16 to the 2/3? You know, you're going to have a calculator portion and you'll have a non-calculator portion on your quizzes and your tests, because I want you to be able to do these things in your head or manipulate them without relying on the calculator to do this work for you, because you have to understand how this works. So we can rewrite this. We can say 16. What is the exponent? So, okay, the exponent is 2/3, correct? What's the power? And what's the root? So we're doing the cubic root of 16 squared, right? That's also the same thing as saying the cubic root of 16 squared. It makes no difference if I take my cubic root and square my answer, or if I square my answer and then take the cubic root. Which would be more beneficial? If you're trying to do this without a calculator, would you want to square a value and then take the cubic root, or would you rather make it smaller by taking the cubic root and then make it bigger by squaring it? I would think you would want to make it smaller first and then make it bigger by squaring it. Haley? It's not the square root. It's the cubic root. Okay? All right, so here we go. This is saying what, if we're going to rewrite it? Square root of 6 to the 3rd. Which, if we were going to simplify this down, isn't that 6 times 6 times 6? So wouldn't this be 6 and the square root of 6? Y'all with me on that? Okay. What am I doing here with the 16 to the 1/4? 4th root of, which is, okay. So we know what to do with negative exponents. We must work with them as positive exponents. So if an exponent is negative, written as an integer, then we write it as a fraction, correct? We flip it. And so this is really 1 over 16 to the positive 1/4. Would you agree? What's the sign change? Is it on the number or on the exponent? On the exponent. It's the exponent that changes signs as it goes from the numerator to the denominator or from the denominator to the numerator. 16 is 16 no matter where it's placed in the problem. Yes? Nope, the root is over just what that number is. So this is going to be 1 over, what's the fourth root of 16? 2. So this is 1/2. So I think some roots you should know. You should know like 1 to the third is 1, 2 to the third is 8, 3 to the third is 27, 4 to the third is 64, 5 to the third is 125. That's as far as up as I'm going to ask you to do without using a calculator. Okay? 1 to the fourth is 1, 2 to the fourth is 16, 3 to the fourth is 5 to the fourth, 625. So some of these you should be able to recognize. All right? All right, so here's the next one. So I'm going to rewrite this one of two ways. I can say 8, what's my exponent? To the second, what's my root? Cubic root. So I can write it like that, right? Or I can write it as the cubic root of 8, and then what am I doing with that value? Which one is easier to work with? Do I want to square 8 and get 64 and then try and figure out what the cubic root of 64 is? Or can I take the cubic root of 8, which I know to be, and then square that answer and get, there we go. In either case, I get 4. So that's why I say it's easier to go smaller first if you can, and then bigger by using your exponent. So then what is 8 to the negative 2/3 going to be? 1 over 8 to the 2/3. And what did we say 8 to the 2/3 was? So this is really just 1 over 4. Making sense? Y'all with me? You sure could. Yes. That would be awesome. And then if your parents can't figure that out, then you just say, but Mom, that's the whole pie. Then you get the whole pie. No. Okay, come on, Mom. 8 to the negative 2/3, that's 1. That's the whole pie.
Mom, if you can tell me what 8 to the negative 2/3 is, you'll give me one piece. But if you can't figure it out,
I get the whole thing. All right, so here we go. So this is 2 to the negative thirds. 2 over x to the 1/3, all to the negative 2/3. So we're using our rules for exponents. We have to take that negative third power and apply it to every part of that term, correct? So that's really saying 2 to the negative 3 over x to the negative 3/3, which is also known as 1. Agreed? Okay. And so I can't work with negative exponents, so we're going to make my exponents positive. And so this 2 to the negative third goes where? And the exponent becomes positive. And this x to the negative 1 goes up top. And so what this really is x over 8. Are we good? This, for some reason, the fraction line dropped out on this one, so put a little fraction line there. It's on mine, it just says negative 2 and then 3. There's no fraction line, so just insert it. Does it? Okay. I don't know. Mine doesn't. All right, so we're going to apply our exponent rule, which we know front and backwards now from the last chapter. And we're going to say that this is x to the... Okay, what's going to happen on my 2? 2 to the 6. And x to the what? So now this negative fourth goes up top, and that's going to be x to the second, x to the fourth over 2 to the 6 is 8 times 8. And so this is x to the what power? No, but you can break it down. If you know that 2 to the third is 8, there are 2 8s then, which are 64. That's how I break it up. Beth? No, you can do it. You should be able to do it in your head, but I'm doing it for you on your notes. Okay? All right, so I'm going to ask you a problem. If I did 3x times 2x, you would tell me it's what? Are you agreeing that this is 6x squared, that we would multiply this 3 and this 2, and there's no distributing going on in this problem? Right? Because we're not showing any adding or subtracting in a parenthesis. So we're going to think about that when we do this one. Okay? I have 2x to the 3 halves times 4x to the negative 1 half. Therefore, this is one term that needs to be reorganized, and our numerical coefficient is what? 8. And so what I have is 8 to the 3 halves x to the negative 1 half, which really that is 8x to the... It's going to be to the second halves, which is 8 to the first. So 2 times the 4 is the 8. And I combine my like bases with my x's and reduce my exponents down.
So how did you do that? Like 3.
Well, what is 3 halves? Yeah, what do you do? When you multiply your bases, what do you do with your exponents? Correct. And my exponents have already like denominators, so it's just 3 halves minus 1 half. Make sense? Moving on. All right, solve or simplify the following equations, rounding your answer to 2 decimal places when appropriate. So get your calculator out. Going to use your calculator on this one. I got to find my calculator. And on your calculator, there's a couple ways that you can do your exponents. Okay? Y'all ready? So if I want to do 8 to the 1/3, that's the cubic root of 8, right? I'm going to show you 2 ways to do it. You can, on your calculator, you can do 8. Turn it on, clear it. I can do 8. This is my exponent key, that little caret, correct? Now, if I want to raise it to the 1/3, that 1/3 has to be in parentheses. And so I get 2. Or, if I want to take the cubic root, I hit 3. And I go to my math button. And I could have just used number 4, couldn't I? Because number 4 is my cubic root. But if you look at number 5 is for any root, really greater than 3. So like 8 or 7. So you plug in your number, cubic root. We hit 5. So that's putting this 3 in for that x right there. Does that make sense? And then the number that we want to take the cubic root of is, and so we hit enter. Okay, so again, 3, math, 5, I'm taking the cubic root of something now, 8, enter, 2. Or, if you know that you've got the cubic root, you can go directly to math and hit 4, because that's going to take the cubic root of whatever I decide to put in there, and that's going to give me the same value. Does that make sense? So, make sure we know how to do this. All right, so let's look at this. So let me make this big for a second. All right, so here I want to take the cubic root of, I've got x to the 3rd is equal to 64. So I need to solve for x. So that means what am I going to do to both sides? Not square root it, cubic root it, or raise it to the 1/3. So that means x is equal to, what's the cubic root of 64? 4. Is it plus and minus?
No.
Cubic roots are either going to be just positive or just negative. Even roots, any even root, positive and negative. All right, so in this case, what do I do first? Or multiply by, so x to the 5th is equal to 1024. So here's where your handy-dandy calculator comes in, right? So what am I doing to both sides? Taking the fifth root of it, not the cubic, but the fifth. So x is the fifth root of 1024. So let's go to our calculator. And let's do, we're going to go to 5, math, 5, because that puts that 5 into the fifth root, and then we're going to hit 1024, and that's the nice even number of 4. No, because notice I said 2 decimals when appropriate. Okay, what do I do on this next one? What do I do first? What do I do? Oh, if it's not on yours, write it on yours.
Is it equal to -5?
Yes. Let's think of our order of operation because it's the inverse when you're solving. Please excuse my dear Aunt Sally is when I give you a bunch of steps. So it's reverse when you're trying to solve. So the first thing I do, is it parentheses or is it my adding and subtracting? Adding and subtracting. So what do I add or subtract? All right, am I adding or subtracting it? Because there's an understood plus here, so I'm going to subtract 2 from both sides. So now, in parentheses, x plus 2 cubed is equal to -7. At this point, half of you will go the right way, and half of you will make this an intensely difficult problem to work. What do I want to do? If I'm trying to solve for x, how many feel like I can distribute that cubed? Yay. Okay. We do not distribute the cubed. Why don't I distribute the cubed? Because there's a plus sign, that stinking plus sign. And what does this really mean? It means x plus 2 times x plus 2 times x plus 2, which is going to give you some cubic, which is ridiculous, because all I'm trying to do really is just solve for x. And x is already nicely isolated, but it's inside that parentheses. So how do I get inside of it? You do the cubic root of both sides. And that leaves me with x plus 2 here. And on your calculator, we want the cubic root of -7. Remember, we can take cubic roots of odd roots, right? And that answer is -1.29. Now, if you notice, I said to 2 decimals. So this is going to be -1.29. Did I say that and I just read it wrong? Okay, sorry. How about this? Is that better? Sorry, I can't read. Maybe I'm dyslexic. So now we subtract 2, and x is equal to -3.91. Does that make sense? All right. So what am I going to do to this problem? I'm going to do the same thing. Take the cubic root. I'm left with x minus 2 is equal to the cubic root of -14. On your calculator, what's the cubic root of -14? All right, make sure you all get it so that you don't read it backwards like me. So what does x equal? -0.41. Are we all good on this? Okay. All right, so then the last one. Can't work this problem unless my exponent's positive. But my exponent is positive, right? My number is negative, correct? All right, so we can do this on the calculator. We can say, where is it? 1 divided by -15 to the 3/5. Oops, but I got to make sure I have my parentheses in the right spot, so I'm going to insert. There we go. And what do we get? And so this is, I said to 2 decimals, so this is about negative 0.2. Are we good? Yeah, this one you'll like. You won't like the next one. You might. It's not that hard. I'm going to get rid of this now. Huh? Sure.
When I was little, at my school, they taught us how to round wrong in 3rd grade.
Oh, no.
I how to estimate wrong. And so then when we went to 5th grade,
Estimate wrong.
so then we went to 5th grade, we were all estimating, and we had like our homework sheets, and everyone would always get zeros, and she'd be like, okay, you're doing it wrong. She wouldn't tell us how to do it. She's like, you learned this in 3rd grade. And our 4th grader teacher taught us how to do it like this too. And then, so she got really mad. We would like fail everything, and all of our grades were really bad. And then she was talking to our teachers, and it turns out that
Coffee for lunch.
Oh, no. I gave up chocolate.
Look at this.
Oh. What a...
I've never given up coffee.
All right, here we go. Ready or not?
she tried to do it.
Okay, properties of rational exponents. Remember, you are not allowed to leave an answer with the square root in the denominator. You may not do that. And if you're adding or subtracting your roots, what's underneath your root has to be identical. So square root of 2 plus square root of 2 is 2 square roots of 2. But I can't add a square root of 2 with the square root of 3. Okay? I can multiply all my roots together, but adding, I have to make sure that they're like terms. So if I want to simplify this, I need to make sure that what's under the radical is as simplified as possible. So 54, I'm looking, it's the cubic root of 54, right? So I need them in groups of how many? So this is 3 times 3 times 3 times 2. Isn't that what 54 is? Because it's 27 times 2. Are you with me? So this is, the cubic root of 54 is really 3 and the cubic root of 2 minus the cubic root of. So how many cubic roots of 2's do I have left? 2 of them. Now don't drop the fact that we're dealing with a cubic root. You've got to indicate that. Otherwise, if you put nothing up in this little corner, it looks like a square root. With me?
Not at all.
Don't do this and expect me to know that it's a cubic root. Well, I simplified down the 54, and I broke it up into 3 times 3 times 3 times 2. But if I'm looking for the cube, because I'm trying to reduce down and rewrite the cubic root of 54, I cannot add or subtract the cubic root of 54 with the cubic root of 2. It's got to be in reduced form first. All right? So the cubic root means I'm looking for groups of how many then to pull out? 3. Now, so I have 3 3's that I can pull out. There it is, right here out in front. What's left underneath the root? This little thing that has nothing to pair up with. So I have 3 of them, and I have 1 of them that I'm subtracting, which means I have a total of 2 of them. What is 3x minus 1x, Haley? That's all I'm doing. And my x is now the cubic root of 2.
Okay, got it.
Good. Good. All right. Glad. Okay? So, cubic root of 250 over cubic root of 2. What's nice is that they're both the same root, right? So does the 2 go into the 250? Sure does. If the roots are the same and I've got a fraction, I can divide them. That's the cubic root of, which is what? Came out nice. They won't all come out nice. All right, here we go. Is this part of this term exactly the same as this part of that term? Then I can combine my coefficients. What is 3 minus 8? Negative 5. And what do I add on to it as my answer? Exactly. That's it. Yeah, you're going to say, is that all? And then half of you are going to do these wrong. There's nothing we can do. Nope. Okay, here we go. So under the fifth root, I have an x to the 10 and a y to the fifth. And I want to make sure that I can simplify it down. Well, what is the fifth root of x to the 10th? X to the 10th. X to the 10th. How many x's are underneath there? 10. How many groups of 5s can I pull out? Therefore, this is x squared. This is the fifth root of y to the fifth. How many y's are under that root? How many groups can I pull out? 1. Do I have a square root in the denominator or a root of any kind? No. Therefore, I'm done. I can have variables in there. I just can't have variables with any exponents. Okay. Here we go. They lost their fraction line, so put it on there again. Okay. So, numerator, denominator. What happens if there's numbers in both? Can we reduce it? Yes. The 6 and the 3 can be reduced, right? What are we left with? Where does it appear? In the top. All right. Remember from last chapter, if your bases are the same, you work with the exponents. Okay? An x to the first over an x to the fourth. I cannot have that x appear more than once as in my answer. What do I do with my exponents? Subtract them. So what is 1 minus 1/4? That's x to the 3/4. And then we look at our y's. What is y to the 3/4 minus 1/4? Y to the 2/4, which is 1/2. I don't have anything in my denominator, correct? Because they were all moved up, so this is just going to be this as my answer. We're going to leave this one alone for a second. We're going to leave this one alone, yeah. Well, it's up. All right, let's do this one. I can't add or subtract unless all this variable junk and roots are all the same. They aren't. But that doesn't mean they can't be reduced. Or simplified out. So, I have a 12 and I have a y. How many x's are underneath there? How many groups do I need to be able to pull out? How many groups can I pull out? 1, but what's left underneath there? How many x's? Correct. But 2 has nothing, I can't pull it out. It's all by himself. It's not like it's 64 or something. Correct? All right, now let's move to the next one. I've got this 6. 512. 512 is 2 times 256, which is 2 times 128, which is 2 times 64, which is 2 times 32, 2 times 2, 8, 2, 2, and 2. So basically it's a whole string of 2's. How many 2's are there? 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is 2 to the 9th. So I need them in groups of how many?
4.
How many groups of 2's are in 2 to the 9th? 2 groups, right? Which is also known as? Right? So this is going to be, right. So I'm going to take out 2 2's. I'll take out 1 2 and another 2. And underneath, I have how many 2's left? A little lone 2. You following this? Well, that's what 2 2's are. So this is going to be, sure, 2 to the 9th. We all agree that this is 2 to the 9th?
Yes.
All right. How many groups of 2's can I take out?
2.
What's 2 squared?
4.
There we go. There's my 4 right there. I took out a group of 2's. I took out another group of 2's. I just took them out individually. I took out how many 2's altogether? 8. How many are left if there are 9? There we go. Follow that now? Well, let's look. We have to break it up and do it in steps. Now we look at our x's. How many x's are there? I need how many to pull out? So I can't pull anything out. How many y's can I pull out? because I have a whole group. So what I have here is 12xy and the fourth root of 2x squared minus 24y and the fourth root of 2x squared. Are these like terms?
Yes. I'm so happy.
Mm-mm-mm.
You said X on the outside and
This has an xy on the outside. This has just a y. Does it? So everything under the roots are the same, but because this one's missing an x, these are not like terms. You've got to really pay attention to detail. Okay? Uh-huh. All right, here we go. Now we're going to go back to this one over here. So here's the rule. Here's the rule that I want you to apply when you get to this lesson. And it's really important that you listen to this because otherwise you're going to get confused. If I give you problems with exponents, you can work and simplify them with exponents. If I give you problems with roots, you need to work with them in root form, and your answer has to be in root form. If I give them to you in root form, as in this problem, then you're going to want to make sure that you rationalize. So a problem like this needs to make sure you rationalize. A problem like this, if I give it to you with exponents and I get one in the denominator, don't worry about rationalizing. Okay? Are you with me? This can be left in exponent form. This one I'm going to want you to write as a root. All right? So let's look at this. This has, I need the cubic root of the fraction x over y to the 8th. So the first thing I always ask myself, first of all, within my root, can I reduce? I don't have any x's or y's repeating, correct? So I can't reduce. The second thing that I ask myself is, I need to see how many I can pull out. Can I pull out any x's? Can I pull out any y's? How many groups of y's can I pull out? Okay. Where's that y squared going to go? In the numerator or the denominator? Because it starts out in the denominator. So this is y squared. Correct? Now, would you agree if I split it, it's the cubic root of x and the cubic root of y to the, how many are left? 2. Okay, so I'm going to come back over here, give myself some room. So I have the cubic root of x over y squared and the cubic root of y squared. So do you see how I need to rationalize this? Okay. So the question you have to ask yourself, there's 2 questions. What root am I dealing with? A cubic. That means I need how many to be able to pull out? 3. How many do I have right now? How many am I missing? That's what we rationalize. And we do this if we multiply the numerator and the denominator by the same thing. Are we multiplying by 1? So if I multiply by the 1 that I'm missing down here under the cubic root, and I multiply under the cubic root up top by that same value, I'm really multiplying by 1, because wouldn't they traditionally cancel?
Wait, is it?
Because how many do I need?
Wait, but you write it under
Under the root. It's got to be underneath the root. Okay? So now, up top, I get the cubic root of xy. Would you agree? And down below, I have this y squared. And this one is going to give me another y. This gives me that. So see how I just lost the square root in the denominator? All right? So hold on, I'll do it again. So this is 3xy over y to the, so let's go through it again. Are we okay with pulling out a y squared? Okay. Do you see how we have 2 of these here? I have to rationalize that, which means I have to get it into some degree of 3. So what's missing under here is 1 extra y, so that I have a y to the 3rd. And if I multiply the top and the bottom by that same value, I'm multiplying by 1. So I multiply the top and the bottom by y over y under a cubic root. So now I have y to the 3rd under the cubic root, which is really just y. and the y up top stays under the cubic root. I moved it from the bottom to the top, but in a way that's called rationalizing, and it's rationalizing higher roots than just square roots. Uh-huh. Well, I just said at the very beginning, if I give you a problem in a square root, you have to see if you need to rationalize. If I give it to you with exponents, you don't worry about rationalizing. Okay? Emily? Okay, let's do this. If I have y to the 8th, take that 8 divided by 3. I get 2, don't I? An even number of 2, what's my remainder? So this is this. Your remainder is what's underneath there. Your whole number is what comes out right there. Is that better? So if I have the 4th root of y to the 17, 17 divided by 4 is 4. 4 on the outside, 1 on the inside. 4th, and then the 4th root of y. Okay, here we go. Write the expression using positive rational exponents, no radical signs. No radical signs. Okay? So none of these signs. So we're going to look at this. Well, this is saying 27 a to the negative 1, v to the second. Raise it to what power? 4 and 6. How do I rewrite that? 4/6, right, which is also known as 2/3. So that's 27 a to the negative 1, v to the second to the 2/3. Okay, so I want you to simplify this. What's the cubic root of 27? What's 3 squared? So that's what this 27 to the 2/3 is. Okay, what is a to the negative 1 raised to the 2/3? A to the negative 2/3. And what is the b going to be? It's just going to be 4/3, right? Can I leave my answer like this? What am I going to do? So 9b to the 4/3 over a to the... Yep. So you've got to keep this as your mantra. If your bases are the same, you work with the exponents. If your exponents are the same, square root of 8, square root of 9, then you do something with the bases, the 8 and the 9. So you look. If you look to see what's the same and what's not the same, you work with. Okay? So what's the same in all of these cases? This is saying x to the 1/3, x to the 1/6 over x to the... So I'm going to add the top exponents and subtract out the bottom, right? So that's x to the 1/3 plus 1/6 minus 1/5, which I think 30 is your common denominator. This would be a 10 and a 5, which is 15, and 15 minus 6 is, yes, 9 over 30. So x is to the 3/10. Is that right? So that's 3, no, this is 10/30 plus 5/30 minus 6/30. Yeah, that's right. Okay, same thing in this next one. Notice the subtraction sign. What am I going to do? I am going to distribute. Yes. So this is going to be 3x to the negative 1/3 x to the positive 1/3, which is really just going to be a 3, because your exponent would be 0, and so it disappears, correct? It's 1. And then minus, what is a 3x to the negative 1/3 with a 4x to the 4/3? What's my coefficient going to be? 12 x to the negative 1/3 x to the 4/3, which is 12 x to the 3/3, which is 1. I can say what because. because I distributed and I simplified out each term. And I applied my rules for exponents. We're going to skip that one. Okay. All right, so instead of you trying, we're going to do this first one together. See that this is in root form? That means we need to think about whether or not we have to rationalize. Okay? So, first thing we do is under our radicals, we try and simplify. Can we simplify any letters? So where is the B going to end up? Okay, nothing with the C, and where's my R going to end up? Are we agreed? Are we okay with this? Okay, so here's the rationalizing. I need groups of 4 for all of these, correct? How many C's am I missing? 3. I have 1, so I need 3 more. Right? You with me? How many R's are missing? Remember, we're doing this top and bottom. So I have the 4th root of B squared C cubed R squared over C cubed R cubed, don't I? No. C 4 R4. Right? Right? What is this going to simplify down to? Down below? A C and an R, won't it? And up on top, I just get the 4th root of B squared C cubed R squared. And that's how you leave it, because it's rationalized. I have no root in the denominator. You don't care if there's a root up top. Rationalizing means getting rid of the root in the denominator. All right.